It says nonlinear systems. That nonlinear means not a line. So nonlinear systems are systems of equations that are at least one, where at least one of the equations is not linear. So in this case, I do have a line and I have a parabola, and I'm going to be looking for the solution is the intersection, which will be these two coordinate points there. That's what you're looking for. What do they have in common? Now in calculus, what it does is allows you to set up the regions that you're going to be working with. So in other words, I would say I'd be working between x equals 0, it looks like, and x equal 4. So it allows me to set up boundaries, one either on the x direction or on the y direction. Engineering calculus, you can go either x or y. I mean you can turn yourself upside down, inside out, backwards. And the brief calculus, they call it brief for a reason. We tend to focus only on x. We don't go after the other stuff. We don't turn ourselves inside out. But in engineering calculus, you're likely to do either. Once you get the graph up, then you'd be looking for what is the area between these two curves. And what I would look at if I was looking for this area, I would need to know essentially where the x starts and where the x ends in order to set stuff up. So that's where this comes into play. And what do I need to do? Well, 90% of the time when you're solving systems of nonlinear equations, what you are doing is you're going to be using substitution. Substitution is the big gun for solving systems of nonlinear equations. Solving systems of linear equations, we found that we could use the addition method if we were going to go back to intermediate algebra. We could use matrices. Matrices send itself up well for systems of linear equations, but nonlinear, not so much. Why? Because the variables involved, even though I just have x and y, I've got x's that are powers, so at which point I can't isolate things like I can with a regular system. So if it's substitution, that means that I'd solve for one of the variables and I'd substitute it in for that variable in the other equation. And if you notice in this particular instance, I have a y here and a y here, so I can substitute in x squared plus 1 for that y. So that says that x squared plus 1, so if y equals 4x plus 1, that x squared plus 1 equals 4x plus 1 using substitution. Bring everything to the same side, 0 on the other, is that this becomes x squared plus 4x equals, minus 4x equals 0. Greatest common factor of x minus 4 equals 0. X equals 0, x equals 4. The majority of the time, by the way, in calculus, that's sufficient. But this is algebra, and we're not doing calculus, so as a result, I need the coordinate point. So I actually want the coordinates for it. Now, my picture looks like x equals 0 and 4 certainly look like that's going to be the case. So my picture verifies that. So I know that if x equals 0, pick one of the two, then y equals 0 squared plus 1, which is 1. So one of my answers is x equals 0, y equals 1. And if x equals 4, then y equals 4 squared plus 1, or y equals 16 plus 1, or 17. So my second answer is x equals 4, y equals 17. So I have to go back to the original equations in order to find the matching coordinate points. So my answers are 0, 1, and 4, 17. And if I come back up here, 0, 1, that looks about right. And here's 4. And if I go over here, that certainly looks like 4, 17. So it's saying that these two coordinate points is what the answer to my problem is. And like I said, in college algebra, we're going to go after the coordinate point. In calculus, I would either want the x value or the y value, dependent upon the perspective of the problem that we're working. in the brief calculus, we'd only be interested in x, so we wouldn't go after y. Any engineering calculus, I could be interested in either problem. Depends. Now here, if I look at the picture, this is the graph of y equals the square root of 4 minus x squared. And this is the graph of y equals 2x plus 4. And if you notice, it happens to intersect, it appears, in two places. And those are the two coordinate points I'm going after. Again, these two y's are equal to each other. So if I know that y equals the square root of 4 minus x squared, and this y I'm going to substitute, 2x plus 4 equals the square root of 4 minus x squared. And then how do I solve that problem? Square both sides, get rid of the radical. So this is 4 minus x squared, but if you remember, this is really 2x plus 4 times 2x plus 4, or 4x squared plus, there's going to be 8 and 8, 16x plus 16. Bring everything to the same side, 0 on the other. 5x squared plus 16x.
4x squared.
Pardon me?
Where'd you put 5x squared?
Add x squared to both sides. So 5x squared plus 16x, and then subtract 4 plus 12. I don't know. Okay. I mean, I look at it. When worst comes to worst, it's a quadratic. What can I do? Use the quadratic formula. But I mean, that's not a particularly fun-looking one.
And then multiply the first constant and the last one.
Yeah. And that's going to be 60, and then, yeah, it's going to be messy. And it's all pluses.
Not worth it.
See, now I get a 10 plus a 6, which is 16. So, took a minute or two. I mean, that's one of those ones that you wouldn't want to meet on a test. I mean, because it's one of those ones you'd either see or you didn't see. I mean, it just is. So this says that x is negative 6/5 and x is negative 2. So I now have the x values. Now, which one do you think I'm going to use to find the y values? Yeah. You think I'm going to put that sucker into this radical? I don't think so. So that's x. So if x equals negative 6/5, then I know that y equals 2 times negative 6/5 plus 4, or y equals negative 12/5 plus 4. Now, if you wanted to use your calculator, you could, but I need to put it over a common denominator, and it's going to be fifths. So that y equals negative 12/5 plus 20/5, or that y equals 8/5. So the answer is negative 6/5, 8/5. I can see I need to reorganize this paper. But this one's going to be easy because it's negative 2. And it looks like it's going to be what? If I look at the picture. Y is going to be what? 0, yeah. It's on the x-axis. So that if x equals negative 2, then y equals 2 times negative 2 plus 4, y equals negative 4 plus 4, y equals 0, which is what we figured, negative 2, 0.